Assalamualaikum and hi, so welcome back. So in this video we are going to look at trial question number 4. So what we have here is the airplane with a wingspan tip to tip of 42 meter is flying horizontally at the speed of 350 km per hour. So basically what we have is the airplane, and the wing of the airplane from the tip to tip has a length of 42 meter and is flying horizontally. So basically ni adalah kapal terbang kita. So your aeroplane will have the wing. Betul tak? Ni macam dolphin dah. Tapi boleh lah. Okay. So the wing of the aeroplane here has the length of 42 meter and they are flying horizontally. Maksudnya pergerakan dia adalah horizontal here lah. So we will have the speed here of 350 km per hour. And then the vertical component of the Earth's magnetic field is 5 times 10 to the power negative 6. So we have Earth magnetic field along the vertical component. Okay, we have aeroplane which is flying horizontally and we have magnetic field from the Earth which is along the vertical. Sebanyak 5 darab 10 kuasa 6. So along here, sepanjang-panjang kawasan ini semua, we are going to experience the Earth magnetic field of 5 times 10 to the power negative 6 Tesla. So the question asks to determine the induced EMF between the wing tips. Okay, so we are trying to find the induced EMF between the wing tips. Untuk kawasan sinilah, for the length of the wings dekat sini. Between the tips, from the tip to the tip here. So EMF dekat sini will be induced, as we know from chapter 5. EMF can be induced when there is change in the flux. However, we have two special case, iaitu untuk rotating coil dan juga conductor moving in the uniform magnetic field. So ini adalah case conductor moving in the uniform magnetic field because you have Earth magnetic field which are uniform along the vertical component. And kita nak cari induced EMF from the tip to the tip, so sepanjang kawasan ini. So this one now act as our conductor which is moving along the horizontal with a certain speed. So ini akan jadi equation yang melibatkan induced EMF dengan B, L dan juga V, because you have the magnetic field, you have the velocity and you have the length of the wing. Okay, kalau kita lupa tak ada masalah. You can go back to the list of formula dekat sini. Equation untuk induced EMF kalau kita tengok, we have from 43, 44, 45, 46 dan juga 47 dekat sini. Ada 5 and then this is for self-inductance punya lah. Okay, so according to the information that we have, kita ada uniform magnetic field, kita ada length of the wing from the wing to the wing, dan juga kita ada kelajuan the aeroplane is flying. So based on all this information we have, equation 44 akan membantu kita untuk menjawab soalan induced EMF inilah. Ini kalau case contoh kita betul-betul tak tahu how to proceed with the question. You do not know. Soalan minta induced EMF tapi kita tak dapat kaitkan dengan apa yang kita belajar. So what you can do here is you gather the information. Keluarkan information daripada soalan. Contoh macam yang kita ada dekat sinilah. Informasi yang kamu ada adalah you have your speed, you have your B. Okay, kalau tak dapat deduce ini sekalipun lagi lah at this particular point, at least kita tahu kita ada B dan V. Okay, antara equation yang diberi untuk cari EMF yang melibatkan B dan V adalah BLV sin theta here. So BLV sin theta, B, V, L dekat sini adalah panjang konduktor lah. Okay, since we are looking for the induced EMF between the wing tips dan juga dia bagi panjang wing itu dari tip ke tip panjang dia. So kita boleh simply assume ataupun ambil nilai panjang wing itu sebagai kita punya length of the conductor dekat sini lah. Ini kalau case betul-betul tak dapat identify lah. Kalau tidak, sebenarnya kita dah boleh nampak dekat sini kan, macam I has explained initially. I said we have aeroplane moving horizontally and you have uniform magnetic field dekat sini. So ini adalah conductor kamu that is going to move across the magnetic field. Thus you will be experiencing induced EMF here. Alright, so B kita adalah 5 times 10 to the power negative 6. L is 42 meter and then velocity here is 350 km per hour. Okay, dia bagi dalam unit kilometer per hour, so you cannot insert this into the equation sebab dekat sini kena dalam SI unit, so kena convert dulu. Okay, so convert dulu. 150 kilometer, so kilo 10 kuasa 3 per hour bahagi dengan 3,600 dekat sini. And then you can press your calculator, you'll get 9722 meter per second. So now dia berada dalam unit SI yang kita boleh masukkan dalam equation ini. Okay, angle dekat sini adalah sin 90. Angle antara B dan juga V kita, they are 90 degree to each other. So kita tekan calculator, you will end up with 0.02 V. This is your induced EMF. Okay, so next we're going to proceed with question for B. What we have in the question here is a coil of 120 turn. So kita ada coil, tapi coil itu mempunyai 120 turn and diameter of 10 cm is placed in the uniform magnetic flux density as shown in figure 4.1. So kita ada number of turn given and we have the diameter of the coil. Okay, bila ada diameter of the coil, hujung ke hujung sini, you can actually deduce the area which is pi r square ataupun pi d square over 4 dekat sini. And then also given to us the magnetic flux density which is the B sebanyak 0.25 Tesla. Okay, and then the magnetic flux is decreased to 0 in 5 seconds. So what is happening now adalah magnetic flux yang tadi kita ada sebanyak 0.25 di mana kamu letakkan coil kamu di kawasan itu, di kawasan yang ada B itu, that B now has been decreased to 0. So perubahan tengah berlaku. Initially we had B sebanyak 0.25 and then we decrease it to 0 Tesla dalam masa 5 saat. Calculate the induced EMF in the coil and state the direction of the induced current. So kita ada dua soalan dekat sini. The first one is to find the induced EMF and then next is to state the direction of current, induced current dekat sini. Okay, first thing adalah kita tahu induced EMF general basic equation adalah negative N d flux over dt. Every time you have change in the flux, kita boleh induce EMF. And then the flux here is equals to BA cos theta. There have to be changes in terms of B ataupun A ataupun theta in order to change the flux. So dalam soalan, apa yang berubah adalah B kita berubah. Initially you had 0.25, in 5 seconds you decrease it to 0. So disebabkan B kita berubah, we are going to write this equation such as NA dB over dt. Okay, and then negative N adalah 120, A dekat sini adalah pi, D square, D kita adalah 0.1 square bahagi dengan 4. This is your area which is pi D square over 4. Kalau nak buat asing and then nak masukkan nilai pun boleh, tak ada masalah. And then dB over dt adalah change in the magnetic field with respect to the time. So dia berubah daripada 0.25 ke 0. So final Tesla minus the initial Tesla divided by the time. Okay, and then you press your calculator. You will get 0.047 V. So this is the EMF that we have induced here. And then next, dia minta direction of the current. Okay, untuk tentukan direction of the current, kita kena guna right hand grip rule. Okay, di mana right hand grip rule ini, fingers kita, 4 jari kita ni akan represent the direction of the eye. And then thumb kita akan represent the direction of the magnetic field. Tapi disebabkan kita nak cari direction of induced current, so B dekat sini pun kena induce B. So before we identify the I, kita kena tahu dulu apa direction of B induced kita. Okay, for that kita kena tengok either flux kita yang berubah ini dia increase ataupun decrease. Okay, if the flux increase, kita akan induce B opposite to the B yang asal ada dalam soalan yang kita panggil B external. If the flux decrease, kita akan induce B in the same direction as B external dekat sini. So let us look at the changes yang berlaku. Changes yang berlaku adalah through B berubah, initially 0.25, finally 0. As we can see, apa yang jadi dekat sini adalah nilai magnetic field kita decrease. B decrease. Since B decrease, maka flux akan decrease because flux is equals to BA cos theta. Bila B berubah dengan menurun, flux kita pun akan menurun. Since the flux changes in terms of it decreases, maka kita akan induce B yang sama direction dengan B external kita. So B external kita dekat sini in the question given, ini adalah B external kita yang cross-cross ni. Okay, cross here indicate B kita adalah into the page. So you have your B external into the page. Sekarang kita akan induce B yang sama direction juga dengan B external, iaitu into the page. So your B induced is also cross here into the page. And then now using your right hand grip rule, thumb kita represent B induced into the page, and then pusing tangan kamu, all the fingers is going to curl in the clockwise direction. Dia akan berputar mengikut arah jam. So that is the direction of your current. I induced is in the clockwise direction. Itu sahaja.